Okay, this is a talk on formulas for what we're looking at is just that ionic compounds, so ones that form ions. So a couple of different terms that we use with ions. One is what we call the cation, and one is that we call the anion. The cations, you'll notice, are all positive in nature. Anions, you'll notice, are all negative in nature. And so these are directly related to where they are on the periodic table, which we'll get to as we go throughout this. Here's some example cations and anions. Notice the anion name, the negative names, all have an IDE ending. That's an important part of this. The cation, the positive ones, don't change. So hydrogen is just hydrogen. Lithium is just lithium. Whereas if you go to chlorine over here, it's actually called a chloride ion. And so the rules with this is, how we name this is you have two parts, one's positive and one's negative. So with like table salt, sodium chloride is the name of this compound. So sodium is the positive ion, it doesn't change. Chlorine is a negative ion, and so its ending changes from chlorine to chloride. So when you put those together, it would look like so. This would be sodium chloride. Now, sodium's a +1, chlorine's a -1, and so they work together really nicely. Same thing with calcium. Calcium here is listed first. It's the positive ion. Positive ion's always first. Then we have sulfur. Sulfur is a negative ion, so we would change it to sulfide. So this is calcium sulfide. Then the last one would be aluminum. Aluminum is 3 positive 3 charge on that, where iodine is just a -1. And so now if you look in the formula, it's a little bit different because it's aluminum with 3 iodines in it. So this is what we call aluminum iodide. Because again, we're dropping this INE ending. Here's a similar slide there. We're going to skip through that. Now, what we end up doing is what we call a crisscross rule for this. So sometimes we have charges that are not balanced. So in the previous case where we had sodium's a +1 and chlorine is a -1. So when we combine those together, these two, this part and this part, cancel each other out. And so it's balanced. Sometimes in the case of aluminum, because aluminum is 3+, chloride is -1 like I just talked about, those are not balanced. So we have to balance them in the formula. And what we do is this crisscross rule. So the crisscross rule is just saying you take the charge from the positive and you apply that to the subscript on the negative. You take the charge from the negative and apply that to the subscript of the positive. And so we end up with Al1Cl3, which we change to just AlCl3. We take this 1 here and we just drop it. Okay, so that's what that looks like there. Here's another example. Aluminum is 3+, oxide is 2-. So we take the 3 positive from the aluminum, transfer that down here to that subscript. Oxide is 2-, transfer that to there, that subscript to the positive. So we end up with Al2O3. Okay, on Wednesday we're going to do a puzzle activity with this. I want to talk about polyatomic ions in my next conversation, so I will stop it here, and you can go take the quiz now.